All right. Well, welcome to this unique Polar Connect event. It's an event of professional development for educators with PolarTREC teacher Lisa Seff. This webinar is open to all educators, but it's part of a course that we are running for professional development on the integrated life and earth sciences in the context of the polar regions. So that's our event today. We are recording it, and it should be available as an archive towards the end of this week, so we'll be sending that out to everyone. Janet was just saying in the chat box, I've been really enjoying all the discussions on the course forum. It has been a really neat discussion going on. So it looks like we're having Julia join us. Welcome. And I'm going to change slides here to a picture of what you are seeing on your screen. And so we've got slides changing, and if you're not seeing slides change to one that says Blackboard Collaborate on it now, let us know in the chat box. That would be helpful. So slides will be changing here. You can participate by using the chat box in the bottom left of the screen, and there is a participant list of who's involved. And we probably won't be using video today in terms of us seeing each other. But if you do want to ask a question, you can raise your hand. There's a little hand icon there, so you can do that. And then as well, when you're ready to talk, you click the talk button to speak, and then you unclick it to finish talking. We also have folks signed on through the phone, and so if things are going on in the chat box, we'll relay those to the folks on the phone as well. So, as Janet is saying in the chat box, you can introduce yourself, but we've got a good group of people, and maybe let people introduce themselves if their microphones are working. A few people have been testing them out. So when you're called, please state your name, where you're teaching or where you are. If you have anybody else joining you, that would be good to know. So actually we'll start with Nell on the phone. Go ahead, Nell.
Sure. Hi, everybody. I'm Nell Herman. I'm a middle school science teacher in Blue Hill, Maine, which is on the coast right near Acadia National Park, and I was a PolarTREC teacher in 2012, so I'm happy to be here today.
Perfect. Thanks, Nell. Annie, would you like to introduce yourself? Looks like she's typing. Okay, she says she's in Italy, and I'm following a polar class. Thanks, Annie. All right, Carol Scott, go right ahead.
Hi, I'm Carol from right here in Fairbanks, Alaska. Teach science in the district here. And I was a PolarTREC teacher this past summer in northern Finland.
Thanks, Carol. And Jennifer, if you'd like to try and use your microphone to introduce yourself. Looks like she's using the chat box. Jennifer Wagner is from New York and teaches middle school science and high school earth science. Julia West.
I'm from Northern New York. I teach high school science, biology, and environmental science through distance learning to homeschooled kids.
Perfect. Thanks, Julia. And we have Justin. Oh, no worries, Justin. If you want, you can try and introduce yourself.
Hey, this is Justin Moody. I'm in Mexico City, and really excited to listen to or check out the webinar today.
Awesome. Thanks, Justin. And Carrie is the next on the list. All right, Carrie's from Fairbanks, curriculum developer for K-12 at the University of Alaska. We have Lisa. You'll introduce yourself a bit in a minute. And Sue, it looks like you're typing to introduce yourself. And we have Janet on too. Janet, do you want to say hi?
Hi, everybody. It's great that you are able to join us today, and look forward to hearing Lisa's presentation.
Perfect. And Sue is typing in, I am from Scottsdale, Arizona, and teach special education science at Howard Gray School, here with Judy Sabatis, if I've got that right. So anybody else who's signing in can introduce themselves in the chat box. Oh, Lucy, it looks like you just signed in. If you've got your microphone working, you can introduce yourself. Okay, she's getting set up. Well, we're going to jump forward just a little bit into how this class is connected to the polar world. PolarTREC is a program that offers professional development experiences for teachers and are getting the opportunity for teachers to go out into the field, as Lisa has done and some of our other participants. And this course is just a small piece of kind of bringing that those expeditions out to a larger group. So that's what our webinar is, and the course is focusing on this particular expedition so we can learn a bit more from Lisa and her team. So again, if you have any questions, you can type them in the chat box as we're going along or raise your hand. Nell, on the phone, you can just interrupt whenever you got a question. We'll jump to you.
Okay.
And so with that, I think I'm going to be able to turn it over to Lisa. I think I've got your first slide up here. Let me know if you're ready.
Yep, I'm all ready. So my name is Lisa Seff, and I feel like I've met and gotten to know all of you on the blog. It's I really can't say how terrific this has been for me. It's just the conversations are great, and some of the ideas that have been added are really great. It's just, as I think all of us know, it gets so busy in education between all of the different national, state, local, Common Core, differentiating, and everything that it's rare, I feel like, we get these opportunities to really have a discussion around some topics together. So it's been great. I've been teaching at Spring School for the last 14 years, doing general education for middle school science, and as well as an Earth Science Regents high school level course for our 8th grade students. And I went and joined PolarTREC back in 2012. I went to the orientation in Fairbanks in February, and then was fortunate to be able to go to Barrow ahead of my expedition to work with scientists and some other educators on putting polar lesson plans together for a week in May, and then went back to Barrow in August of 2012 with my expedition, exploring the oceanographic conditions of the bowhead whale habitat with Dr. Ashian, Steve, as you all have met with last week's webinar, and Dr. Robert Campbell out of URI. And one of the first things, I tried to adapt a few things to some of the conversations that were going on during the blog sessions for the last week and a half. And I think what was mentioned and what I use with my own students are the differences between the Arctic and the Antarctic regions. And the polar regions are such a natural draw. I'm not sure if it's a curiosity about the extreme nature of each region, that it's still under exploration, just the different habitats and animals that are there, but it definitely is a great hook to pull kids into science. So so I put these pictures up because these are some of the first diagrams that we were shown at our PolarTREC orientation. I think it's a great diagram between the Arctic versus the Antarctic. And as some of you mentioned, Venn diagrams or whatever means you often get kids to contrast and compare is terrific, but don't forget to also pull in wherever you live. And the ocean surrounded by land, land surrounded by ocean, you really get a wow, not only from students, but when I've presented to adults at all different ages. It's something everyone just nods and sits back and says, oh wow, I never really thought about that. And that's a great place to start. And then you can go into the animal habitats. Polar bears versus penguins is such a classic, and we actually had a postcard project at my school where before I went back to Barrow, students made their own postcards, and as you'll see in a later slide, we shipped them in a box up to an educator in Barrow, Matt Conforti, who was nice enough to take all 600 plus postcards. We are a pre-K through 8 school, and so that they would actually get a postmark from Barrow to be sent back to them and remind them about the expedition. But one day in art class there was a substitute, and so she didn't realize that there were no penguins in the Arctic, so consequently some of our Arctic postcards had penguins on them. But it was a good point for discussion. And I see that the question about the sea ice, and I think that's a great question, is why is it thicker up there? And I'm going to I'm going to guess you get more of the actual loose sea ice. You have more of it that's actually year-round, where the Antarctic, you don't have it contained within such an area, so it eventually floats and melts away. This is different than, say, the glacial, whether it's continental or valley glacier ice. We're just talking sea ice in that section. And then another thing that was brought to our attention was mosquitoes versus no mosquitoes. And again, a lot of kids have experience with mosquitoes, so they sort of get that idea. And I know we have some people, someone I think Nell up from Maine, so you know, and your kids know about mosquitoes. And there's a great video that I did put on the link at the end, which is also showing researchers having fun and sort of poking fun at their working conditions. And they did a special dance outside at Toolik Station to Michael Jackson's Thriller with mosquitoes all in the foreground, background, wearing full mosquito gear. So that's something, again, that kids don't think about, and then you can go into discussions about why would some areas have mosquitoes and other areas not. But that's a great video. And then pulling it into talk, again, getting them talking about your local area and making comparisons there. Next slide, please. So I think besides introducing Arctic, Antarctic, and our own region, a classic question to bring to kids, and if you can get drawings, and we're actually going to move on to try to do this a few times this year, is to have them draw their concept of a scientist at least 3 times over the course of the year to see how does it change and how does it compare, and then look at when those students move up to the next grade and see what their starting of the year diagram is of a researcher, instead of just doing it once. I really like this idea, and so we're just sort of putting that together. And you classically get these diagrams, usually male, not always, but usually, and in a white lab coat. Someone's usually on fire in at least half of the kids' drawings, and there's test tubes all over the place, which is definitely part of it. But I think I'd be interested in what the actual percentage is of scientists that are in the lab and wear a white coat. My guess is it's pretty minimal. But it's good to get them thinking about it and get asking those questions. So this is a slide that I start off with early in the year. So next slide. So then I introduced the kids because we were part of this expedition, and we actually had, although I teach middle school, we had our entire school of now I think it's 740 students on board with this. I was actually, when I was in Fairbanks in February, I was Skyping live sometimes during class, if Sarah remembers. Catching me one time, I hit the wrong button and the Skype came up, and all of a sudden I wasn't just sitting in my PolarTREC orientation, but I was sitting with my 4th period biology class, which was pretty funny. But they loved making those connections and live with the Skype, and sitting in a snowbank, I Skyped with 600 students at once in the gym. And I guess when the picture screen came up of me sitting there, the roar of the students was amazing. And most of these kids I didn't know. So it really taught me the power of talking to them live from location. And I don't think you'd necessarily have to be in the polar region. You could actually go to a habitat closer to home to connect not only to your own students, but also to students that might be coming your way in a few years. Because you can really hook them early, and they're so excited about it. That was really a great experience. So in my classes now, I again go back to some of these pictures just to get the kids thinking about, oh, scientists don't just work inside and don't just work with the lab equipment, test tubes and things. And wow, I don't see a white jacket there. Next slide. And then part of that connection, and I think it's so important to make the connection that these are regular people. Just like they're, your kids and your students and your community members are regular people. They're just passionately curious about something, but they act and do most of the same things that many of us do, and eating is part of that. Steve was the bacon guy with the bacon beans and I think he had bacon Band-Aids there too. It's his birthday whenever they've been up there, so someone sent him a whole box of bacon goods. And then we had Oreos, and just the kids get a chuckle out of that because, again, it's just letting them in on understanding that the scientists are just regular people, which I think helps them connect to them much more than picturing them in an environment that they can't imagine themselves in. And it also gives you a chance to pull in that research involves much more than just researchers. The boat captains, the technicians, the support staff that handles the business side of research. And that pulls in so many other students other than that might not think of themselves as a scientist, but think, wow, it'd be really cool to go there. Even I've had students that love engine repair and picture themselves as becoming a mechanic ask, wow, who fixes the boats up there? And they need boat mechanics. And there are many aspects of research that can pull kids in from all walks of life and whatever their interests are. Next slide, please. So again, this is sort of pulling back a visual to help them make connections to the big picture by linking where you're talking about to where they live. And I think I know especially for us, even a lot of the maps, when I started looking at maps that other teachers were using to show the geography of the United States, it's funny, often the map is the contiguous 48, but then it shows Alaska and Hawaii sort of floating separately off to the left of the main map. And so if you sort of ask kids to draw where Alaska was, many of them had no idea because they hadn't really seen it in a reference to focus in on it. So I think connecting that and giving them latitude, longitude in the middle school really connects to part of my curriculum. It gets them again, looking at the big picture and being able to envision their connection to the locations that you're talking about. And next slide. So continuing with where scientists conduct research and what type of vessels. The picture on the right of the Nor was actually docked at Woods Hole Oceanographic when I went up to visit Dr. Campbell and Dr. Ashian were up there, and they gave me also the picture below, which is of the ship when it was obviously in very cold waters, but just giving some of the conditions that. Whoop. Can you guys still hear me?
Yeah, Lisa, I can hear you. Perhaps did someone else just join by phone?
No, I think I'm good.
Yeah, this is Matt 40. I was able to get on.
Oh, I think I hear Matt Conforti calling in from Barrow.
Correct.
Cool. All right. So Lisa was just kind of introducing her project and the team she's been working with, and you have the PDF to follow along if you're there on the phone?
I do.
All right. I think we're on slide 11, pictures of the ship and a polar bear right in the middle. So Lisa, I'll turn it back over to you.
And Matt is the one who just joined us. We were just talking about you, Matt, and about the postcards that he mailed back to my students during the summer before I left. So anyway, this just continues with pictures. This was the Quonset hut that researchers stay in, and it's 166. It's actually the one that I stayed in with a couple of other educators in May. And the polar bear signs, the kids have such a natural interest in polar bears that there are always, true stories either that we were involved in or that other researchers talk about. So again, it's bringing up the natural interest of the area and where researchers are working. Next slide. So one of the most common questions that I get is, what do scientists study? And so with this direct research and jumping onto really any of the PolarTREC sites gives you a great view of what scientists are studying. And so we talk about bowhead whales, we talk about the prey that they eat, we talk about the ocean currents that can be studied. And when discussing the difference, the kids, look at the size of the whale and the zooplankton, and one of the first things they think about is, how can that possibly, the whales get so big? when they're eating such small prey. And in fact, I'll usually pass everyone like one chocolate sprinkle at any age and say, you know, and they'll eat it, and then they'll look at me like, where's the rest? And they realize that to fill up, they'd have to eat quite a lot. And when you tell them that whales typically can eat 2 tons of krill per day, they start getting a better idea of how much these animals, the caloric intake they really need to get to reach the sizes that they do. Next slide. So then it's going into what do scientists study and how does a research project begin? And it's great for the kids to know that it really starts because someone is wondering about, you know, why something is occurring or how something's happening. And that's in this case of how the research team started with this project. Is they started noticing through aerial surveys and hunter interviews that there were quite a few bowhead whales congregating off the coast of Barrow. And this also gets kids started to look and use aerial surveys and realize that a lot of science is now, fortunately, not just researchers in isolation. They're working quite a bit with native populations, and it also starts to bring in the native populations that exist in the Arctic region, because going back to what's often taught, at least in many of the schools around me, the native populations discussed are the contiguous United States native populations. And it's a great introduction through looking at Arctic research, because so much Arctic research is now being influenced by the local Inupiat populations. So it's just a nice way to bring that subject in. And if you can work with your social studies teachers, you can make some nice connections between the science and the Native American history of the regions. Next slide. And so again, I think it's important to, and it works really, really well, if you can take a complex research project and bring it into something the students are comfortable with. And I think in so many science classes, they hear the scientific method over and over again in maybe a little different form from each teacher and each textbook, but basically it's the same thing. So if you can take a complex subject and break it down into the steps that they're familiar with, all of a sudden you see them nodding, going, oh, I get this. And it even, it really works for students of every age. I've pushed into grades K through 12 and the senior center locally, and breaking it down into the scientific method really seems to connect with everyone, people of all ages. And next slide. So we go from your classic developing the research question, and then I explain that, well, then they have to actually design a research project where they can collect data to answer the research questions. And we talk about going back to those whale sightings and whether it was aerial or based on hunting background. And then we talk about the researchers actually laying out, all right, how are we going to do this? We're going to be towing the Acrobat and a ADCP out, and then we'll be doing actual trawl and ringnet samples coming back, and laying those lines out where the boat's going to be traveling is part of the whole experience. On the next slide. Probably one of the biggest impacts to my immediate teaching was being able to really explain and show students what tools scientists use, which again, I know I saw some recent discussion about how to introduce those tools to the students. And when I first went to Barrow, my initial thought was to be taking pictures and writing the journals, and then the minute I got out on the boat, I was like, oh my gosh, I wish I could bring all the kids with me. And that was what really made me switch from doing just photographs to starting to use the videos, because I felt like I could really capture what it was actually like if the kids could see the rolling of the motion and actually see the instruments in use. And so maybe at this point we could show that video. Sarah, would that work for you?
Yeah, sure. So I've got it loaded up here. It looks like, so the way this works is I've loaded a video here, and it should be sort of buffering for everyone, depending on your connection. So hopefully it does work. I'll press play here, and it should send you off to watch this video, and we should all be watching kind of at the same time. When I see that my video is getting towards the end, I'll speak up or write in the chat box just to see if we're all in the same place. If you're on the phone, we won't have it for you to see through your phone, I suppose. But I sent it out to Nell, and Matt, I'll send it to you as well. So it should be coming up in a second. All right, so I think mine has ended. Is anybody still watching through our platform here? Okay.
Okay, do you...
I think people are done.
Sorry, go ahead, Sarah.
Oh, no, go right ahead, Lisa. I think we are all good to go.
Okay, so just as mentioned, I think the kids are so curious as to what do they do. And so I ended up doing, I think I made, I don't know, 5, 6 videos total. So that one was, I think 2 of them were sort of our typical transect days. We actually had a lot of stormy weather, so we didn't get out too much. So I wasn't able to get everything done that I wanted, but I tried to capitalize on what we did on the days we did go out. And the kids really get excited about that video, and I've used that video with first graders, again, through all ages. And the music helps. I use music a lot in my classrooms, and the music really keeps them entertained and gets them interested. For my students and the older students, it gives us a platform to then move into they can't wait to learn more about the instrumentation that the researchers use, which also allows a natural connection into the labs that we do that are based on a lot of the instruments. The picture you see there is it's also good for them to learn about, not only do we use instruments on boats that are underway, but scientists also put these moorings out. And some moorings are short-term for possibly a few weeks, and other moorings, are out for a year's time. As Steve mentioned, the last mooring they put out, the year-long one, they were not able to retrieve. And that's part of science, and that's part of, again, the kids, it's great for them to hear, not that something didn't go well, but that not everything works the way you want or hope it does. But that's all part of science. Making mistakes is okay, and you learn from it. And so I did a different video that we won't watch today, but I ended up using the Carly Simon anticipation music with the mooring retrieval for the one that had been out for a year. The one you see us in the picture was a short-term mooring, but we did pick up one that had been out for a year, and it did come to the surface successfully. But boy, everyone's holding their breath, and the kids found that very exciting. And they also loved seeing how much computer technology was used, not only in the moorings, but also you saw the picture of Steve in the small boat. We have a whole row of computers. And the oceanographic moorings measure and record the weather in the ocean. Weather is sort of in parentheses. A good question. That was actually Steve's language. Just like you get atmospheric weather, you get different conditions occurring within the water column itself. The moorings measure everything from salinity to the density, conductivity, temperature, scatter, background particles that are actually in the water column. So all of that is sort of classified within that weather term, is what we were looking at. And building on students' prior knowledge, you can have them brainstorm what does a mooring mean to them. And if they live anywhere near a large freshwater body or saltwater body, to them they always picture the mooring always on the surface. So they're very intrigued by realizing that you have computers talking to each other, that this mooring actually goes to the bottom without a line going to the surface until it's time to retrieve it. And so they find that pretty exciting. And it's just another example of equipment that's used, and pulling the technology into it really gets them interested in it. Next slide, please. So a lot of looking at the actual data, I grabbed some of the slides that Steve had shown just because you're familiar with them, but a lot of it is just giving the photographs to the kids and letting them look at them and decide what it means. And it's pretty amazing. They come up with very similar answers that the researchers do by looking at some of the data. And so I put this one up. This is similar to some ones that I've shown the students where they see the sediment or the ice acting as a tracer for the krill, and why in one picture does it appear to be moving around the corner and the other picture the ice is not. And then they also see what the wind speeds are, so they start hypothesizing what's going on. They're also using charts showing the depth so they can see the shelf and see the shallow areas, along with current maps. And it's pretty neat what they're able to come up with. Next slide. Actually, you can go back one slide again. Something that was simple even to get some of the idea to them, and it depends on the age group and it depends on the lab you want to do. But even simple things like having a tub of water and whether you're using dye or you're using clay particles or Rice Krispies is moving, how can they move the particles from one end of the tub to the other end of the tub and give them straws, and they start connecting that it's wind that creates the ocean currents and actually moves the things that are in those currents. Thank you. You can go to the next slide. And they want to know, okay, you have this machine that's attached to computers, how does the data look? What do scientists actually look at? And so they really do like to see the different, we don't have the programs that actually make and show these things, but I can show them the final result once the researchers have sort of plugged all of the mathematical data into the programs, what comes out the other side. And again, they can look at it and start to, if you realize that, oh, the krill seem to like being in the colder, saltier water, and then where is the colder, saltier water, and why is the Alaska water have more fresh, less salt in it than the Pacific winter water, and that brings up discussions which allow you to go into labs that support the science more. Next slide.
And Lisa, I'm going to jump in. There's a question from Julia. It says, but don't the currents go the opposite way that you showed the wind going?
Where are you on the last? Go back. Maybe was it the back? I think the last slide. No, if you look, do you see the little pink arrows up there? So that's the wind, and maybe you're looking at the greater than or less than. That's just greater than or less than how many meters per second that the current's actually going. But the pink arrow shows the direction of the wind and the flow of the current going from right to left or east to west.
Okay. Yeah, it looks like she's typing. Oh, okay. She says, no, I guess I thought all the currents went from west to east.
Nope. Up in that area, they don't. You actually have a lot of circulation going on up in the Arctic with the gyre and the different currents entering the area. So right along the Barrow coastline, and again, it changes depending on where the wind direction is from, and the strength of the current changes depending on the wind direction. Yep, Beaufort gyre. And next slide.
Right. Let's see. I just want to make sure, Julia, did that answer your question or kind of clear it up?
Oh, good.
All right, great. I'll move on.
And the next slide. And then letting the kids, and I know that you've seen this slide before, but I really wanted to nail the concept of attaching this to the scientific method so that the kids you can do this with any type of research, is just break it down. And you can even do it with something, sort of silly on the side to help them get it. I showed someone broke the Monty, I can't think of the name of it now, the Monty Python, the Holy Grail video down with there was a witch scene in there, but someone broke that down into the scientific method, and my kids got a big kick out of it. But you can really do this with any complex research, and it's a way for you to simplify it for the students and break it into language that they are used to hearing in science. Next slide. And then you can go from there to start make connections to the science within your own region. So in the upper map is the bowhead whale migration with the bowhead whales below. On the right-hand side, we live on Long Island. We actually recently had some humpbacks, quite a few humpbacks that were seen off of the island. But here I show the North Atlantic right whale migration pathways up and down the East Coast. So it's again trying to make connections, similarities, differences between the two regions. Next slide. And I know when I get most students, when they think of a model, they're really visualizing a model that they're making, a real hands-on model. And even though most of those models are based on math, and they don't really understand that. So starting to really introduce them to the mathematical models that researchers often use, using real research is a great step for that. So they love the idea of these mathematical krill that are plugged into a formula to see where they go. What they're more comfortable with is the hurricane models that they actually see quite a bit, and they're used to seeing to get, oh, models can sometimes be a prediction of what's going to happen. So that's why I threw in the hurricane model. Just that's several mathematical models that are used to make predictions about why something's happening or where something's going to occur in this case. And then on the lower right-hand side is the sea ice extent, observations and model runs. So how much ice we thought, researchers and models showed there should be at this point in time, and how much ice, the red line is how much ice there actually is. Oh, and I saw the note about the bowhead whales. On that trip, bowhead whales really start to come in late September typically. On our last day, on our last trip out, we actually were surrounded by bowhead whales, but up until that point, we hadn't seen them. And it was one of those classic, every time I didn't have my camera was when one was close enough. But we did see, Steve had a picture. We weren't able to get a good one on my trip, but I saw that Steve put one up that Phil had taken on their recent trip up there, showing the blows in the distance. And that was really what you saw. You were surrounded on the horizon by bows. And there may have been some gray whales because we weren't close enough to all of them, but the gentleman we had on board, that was actually Knock, thought that the majority of ones that were close to us were bowheads. So that was really exciting to see those whales. And so actually we can go to the next slide. And just bringing up, because I know there were starting to be I know there are educators from the polar regions, whether it's Barrow, Point Hope, or other areas. You have an amazing opportunity. It was so exciting that after my expedition, PolarTREC sent me to Point Hope, where I met up with another educator, Christina, and Dr. Ashian flew in for the last day, but I had 3 days pushing into the local school, and it was sort of science teacher on steroids, where Christina set up where I went from like a kindergarten class to a 9th grade science class to a 1st grade science class to a high school technology class and it was a couple days of that. On the last day, Karen Ashian flew in and joined me for the high school level discussions, and it ended up being such a great collaboration and discussion with the high school students because so many of them were whalers. And we explained and showed the currents that the krill that our researchers were studying off of Barrow were Point Hope krill also, and that the currents were part of the same current system. And they were so interested in learning more about conditions that brought whales close to the coast. And it ended up being I get chills because it was this amazing back and forth discussion. And I loved it in one of the classes at the end. This boy who was, probably 16 and a whaler, on his way out, he banged me on the shoulder, but in a nice way, and he just nodded his head and he said, "Thank you so much for not being boring." And he walked out, and you could tell he was like the ruler of the kids. And Karen looked at me and goes, "Is that good?" I'm like, "Oh, you're kidding me? That's great." It was it was just the kids were so engaged naturally to the research, and they were excited to hear that researchers were working with the local people and hunters to work together. And that's something that the North Slope Barrow does amazingly well with their research and connections to every study that's up there. They really work with the local people. And their website, much of the research that's on their website is really the most up-to-date information you can get on all of the everything from the permafrost to the microscopic organisms and the polar bears and the whales, bowhead whales themselves. It's pretty amazing connection that's going on up in Barrow. But it was really amazing to be able to jump into the Point Hope population, who they were very welcoming, and it was exciting to jump to all these different classes, and every group was really excited by it, and I was able to use the movies and the video clips, and it was great. So pulling back to my classroom, I have some pictures. One, there's Matt, so I don't know if Matt can see the slide, but that's Matt Conforti from the Barrow school system delivering the 600 some odd postcards. So that's a way to get kids connected. One, nowadays kids don't get mail or have much to do with mail, but my elementary teachers thought it was a great moment for them to do some writing as well as some artwork. Some of my students, that's a land-based versus sea ice-based melt. What's the difference? And when people and students hear about ice melting, they really don't think about the differences that occur. So that's just one lab that we did. We also go into the ocean current temperature, oceans, and salinity labs, and we have the PolarTREC resources, but I can also really say the Seymour site out of Hawaii and the kits that they provide to educators for free. And if you're too far away to get a kit, because maybe some of them you actually have to pick up, although some of them can be mailed, you can download all of the lessons that surround the kits, and they're really terrific resource. And they're resources that you really don't have to do much to, which is not always the thing that happens. And then my researchers came up with the zooplankton bingo idea, and we actually through Seymour got a grant where we were able to get a computer-connected microscope and plankton net. And if you go to the next slide, these are zooplankton that my students actually took pictures of. And I love Justin's quote. The first time I did this, it just is amazing. The kids go nuts. And it's great if you want to really get kids interested in how to use a microscope, let them look at what's in their local water. And they were so excited. So part of the idea, and I haven't done the bingo yet, is to, and eventually I think I would make a bingo card out of pictures just from student-generated photos to make it a little more personal, is to have them at least start to get some close identification ideas. Because sometimes the big identification books or what you have on zooplankton are pretty complex, that it's a little tough for many of the kids to be able to use. So we thought that the basic bingo idea could work out pretty well, but I really cannot say, and those really were Justin's words, and he's not, he even said, I don't normally like science classes, and this is awesome. And so whether you have fresh water or salt water, you can find plankton in your water. So it's just terrific. Next slide. And then it's going beyond some of the research, but it's also what the research pulls in, is that on the left, and Sarah can probably say, I forget the name of the coal lab up outside of Fairbanks.
Yeah.
That
the Coal Climate Housing Research Center.
Great. And those are actually their solar panels. And when we first got out of the car, I looked and I was like, oh my gosh, how cool is that? And it's great. If I give these two pictures to my students when we're talking about angle and duration of solar radiation, it gets them talking and let them figure out the why. The diagram connecting the two is actually, we get data generated from our solar panels. And I had called the Cold Climate Housing Research Center, and they were actually able to give me some of their data, so then students could compare the data. The Aurora Borealis captures everyone in that imagination, and the University of Alaska Fairbanks, their Geophysical Institute, has those 3 pictures are taken from the same night. So you can go online to see where the aurora is going to be, how great it's going to be, and then you have the other more satellite version of it, and then we went outside and actually saw the aurora. So that was all back in February of 2012. Getting the students to use aerial surveys, because that's what scientists are using, and comparing what are they looking at. So up in Barrow, there's so much focus on the sea ice, and versus closer to our home, it's directly on the beaches and the erosion that's occurring there. And then charts with tracking where bowhead whales are seen using latitude and longitude. They find that, I think, seems to be more interesting than just plotting random latitude, longitude. Let them plot where whales were seen. And so again, pulling it closer to home, it's a great introduction to local charts and you know, discussions about things that we need to cover on local topics and topography and bathymetry. Next slide.
And just to let folks on the phone know, there's a quick discussion going on in the chat box about the Aurora Borealis and when does it happen. People are sharing links.
Oh, great. And so much of what it seems I'm teaching with climate and weather impacts and connecting to the oceanography, it makes the whole, really my whole curriculum connect. But it's getting the kids to think, and again, this is looking at modeling. And this is a model from a New York Times site where you can, and there are many of them online, if you just sort of type in that you're looking for a sea level rise models for your area, you can find quite a few. I like this one the best, and you can zoom in on your areas also. But so the upper left is, I think if it was at sea level, and then it goes up to 5 feet higher and then up to 12 feet higher. And then I just pulled out some quotes from local areas, even farmers discussing that it's a mixed blessing. They may have a longer grower season, however they realize they have to install more irrigation, and they're starting to see more invasive species and pests take hold. And this is something that my English teacher and I are discussing is, for the Common Core, what's awesome is that's really tilted things back to nonfiction. So she's looking at what things can she have the kids writing about, and she's excited to use climate change and sea level rise and as a base. So we were looking at articles around us, and then on the next site, this is I gave the link for the climate change and Point Hope site that was recently on our blog site, because they had some great discussions about all of the impacts. And the top left picture, unfortunately, the little tiny, very small plane that looked like the boy was about 12 who flew us into Point Hope. That's Point Hope, what you're looking at right there, and it's a peninsula that sticks out at the other end. And it's really like a gravel island, and it's so flat. And they've already moved the town back due to sea level rise, and they have barriers built along out of gravel and sand to help prevent the ocean from coming in. When one impact of having less sea ice for shorter term is that ice protects the shoreline from as much erosion. And so there's a picture actually of their cemetery. They had a beautiful dance, native dancing going on one night at the school. You can see me coming out of one of their original homes that up until late 60s, and I think one guy told me there was someone still living in one up until the early 70s. The houses were built out of whale bones and sod. And I'm very careful at talking about the whale hunting with my students because it's has such a personal impact. When people see a whale that's been killed, it really hits so many people in the heart. But you have to go up and live in these areas to really understand how much a part of the culture it is, how much they rely on the whales to truly feed their population, and it's just woven through every aspect of their culture. And they have such a high respect for the whales, and they're so careful. And I think I saw one question on the blog about, do they really use all of the whale? And they really use all of the whale. I got it in Barrow, but when I went to Point Hope, it was just really an amazing experience. So these quotes are from that climate change in Point Hope link that I posted on the blog. And again, this is hopefully connecting. We'll be using some of the articles within that paper for our students to get a handle on some of the impacts that are occurring because of climate change. So it's sort of that food for thought. The one picture in the lower left-hand corner there is actually from Barrow back in back in May 2012 when I was there. The sea ice was, you can see it's just starting to melt. Whaling season was going on. Elizabeth was actually up there, and we went to a house because one of the things that they do once they catch a whale is they put their own whaling flag up, an oar with their flag up on top of the house, and they share it with everyone in the area. And then they also disperse large amounts that are stored in their cellars in permafrost that isn't as permanently frozen as it used to be. So that's a great part to bring in, is just the humanity of the situation also. And just touching on other things, density and salinity and temperature salinity graphs are easy connections to make with the students. And I'm actually working on a mini grant to get professors at Roger Williams University and University of Rhode Island have used GPS tracking devices that are normally used on 18-wheeler trucks to track them. And they actually have some waterproof models that are usually put on the outside of the trucks that a couple of professors at the universities have successfully used to attach to buoys and float them, and there's a great tracking program online. It's very easy to follow. So that's something we're working on, so that hopefully students can again connect what's happening and see and track our local currents, and by tracking the local currents, connect with where do our plankton go. I think that's the last slide. Oh, and I threw up some books, some artwork. Different people have spoken about artwork. The TED Ed talk about the secret life of plankton gives amazing visuals in that video. And you can see there's an Inupiat parka that I saw at the University of Alaska Fairbanks when I was there. That's made of recycled plastic bags, it was amazing. It was beautiful. The Arctic animal masks, just drawing ideas. If you haven't been to Beyond Penguins and Polar Bears, that's a terrific online source for elementary student reading. They have leveled readings on all topics about the Arctic, and it can also read the books to the students out loud. So, and the Sea Soup books are terrific resources. And I know a few people also mentioned Escobar the Oil Man, which one of my researchers she's quoted in there on some research discussions within the book. So those are just some sort of last ideas that I put in there. And that's it.
Perfect. Thanks, Lisa. All right, so people are sort of writing clap, clap, clap in the chat box and saying thanks for participating. Thanks for the webinar, Lisa. Really informative, and I think it's really helpful to know how you are actually bringing it into the classrooms. So if there is any questions, people I can see are typing. If you have a question that you wanted to ask live, you can raise your hand. We're sort of at the top of the hour here, so I know some people need to jump out. But if there are any questions, or Nell, or I don't think Matt's on the phone anymore, but Nell, if you're still there, if you have any questions.
I am. No, I don't, but I just want to say thanks. That was great. I've jotted 10 notes here. So, yeah, thanks so much. Yeah.
Yeah, well, it looks like people are signing off. Our friends visiting from Italy said it's 1 in the morning there, so it's time for them to head to bed. But Lisa, thanks so much, and she's saying thanks to everyone as well. And so the archive will be available. A few more slides here is one of resources that Lisa has. Those will be available. And the webinar archive will be up probably tomorrow, if not before the weekend. So thanks so much for attending, and check back to see if we have more events coming up.